Hello, welcome back to Cracking the Cryptic, and it's a hot day. It wasn't when I went out, but it was by the time I got back, and I've just got set up with a little breeze between two open windows, and that's good. But if my brain is a bit more fried than usual, that's my excuse for worse than usual solving powers. Now, I hope I don't have those, because this is another puzzle from our friend Glum Hippo, Philip Bloomer, who has created a variation on his XY diamonds. And this is going to be interesting. I haven't really got to grips in my mind with the rules at all, so we can do that together. We'll look at that in a moment. Don't forget that on Patreon we have the worm style puzzle hunt called Regeneration, as well as crossword and connection videos. On our apps, we have all sorts of killer Sudoku type puzzles and domino style puzzles too, but also Fog of War and the worms from James Sinclair and Marty Sears, which we commend to you. There's also SVEN'S SUDOKU PAD linked in the description field, but the first link is to this puzzle, and it's called XY Cages by Philip, and I will try and explain the rules as clearly as I can, and maybe then I will understand them as well. So, normal Sudoku rules apply. 1 to 9 goes in every row, every column, and every 3 by 3 box. A white diamond between two cages, means that the difference between their cage totals is equal to the topmost or leftmost digit in the column or row in which that diamond appears. Good grief. Okay, so let's colour that one yellow. I've really picked a silly one for exposition here, and that one pink. Let's say that digit was a 3. The difference between the total of the yellow cage and the pink cage is 3, because this diamond is in column 6 and the top digit of column 6 is a 3. Now, let's make this blue. What is the difference between the sum of the blue cage and the pink cage? And the answer is this digit. Let's say that was a 6. So there'd be a difference of 6 between the sum of pink and the sum of blue. Now with a black diamond, we're looking at, say that was 2, then this could be double that 2 times. Because I didn't get onto the black diamond rule, but it is obviously about ratios. Sorry, a black diamond between 2 cages means that the ratio between their cage totals is equal to the topmost or leftmost digit in the column or row in which that diamond appears. It's exactly analogous to the white diamond rule. So that 2 governs both that black diamond and this one, and requires the same ratio between this Z-shaped pentomino and this O-shaped tetromino. Digits may not repeat within a cage. Not all possible diamonds are necessarily given. That's it. That's all we get. Well, okay, I understand the rule now. I'm restarting my clock. I'm going to say, well, let's do it again. Let's get cracking. Do give it a try on that link below the video. But I suspect you'll see a good long video solve time for today, or video length anyway, indicating the solve time. Right. Normally with black and white dots, you begin with consecutive black dots. I mean, okay, I am going to actually keep colouring the cages because I think it's quite useful to discuss them. And I don't know, I may be going mad here. Let's try linking those to start with, because these are all connected by black diamonds. But the ratios can be totally different every time. Well, not totally different every time. Whatever digit is here, I'm just going to be, I obviously hit the wrong thing there. Let's call this X. The ratio between red and yellow is X. The ratio between yellow and blue is also X. The ratio between red and green, though, is Y. And the ratio between green and pink is Z. Of course, X could be the same as Y or Z. Oh, man. What does that tell us then? Precious little is my suggestion. I mean, I suppose all the cages do seem to be linked somehow. So this blue links by a white dot, which is governed by a difference from this cell. And then I don't know. There's a 2-cell cage linked by a black dot to a 6-cell cage, but that's easy. This could just be a high digit. And then that's easily done. Okay, there's a 1 here. So for this dot, we know what the difference means. It means a difference of 1 between that cell and the pair here. But it could be 1 higher or 1 lower. I'm despairing here. What on earth are we meant to do? Philip, what are you up to? I cannot see a single point at which it would even make sense to break in. So apart from this X, which governs those two, I suppose Y governs that ratio and that ratio. Okay, it's going to be low, therefore. I was going to say this was the only cell. And normally a white dot in that position indicates that that cell is half that cell, but it doesn't work that way here at all. It doesn't do that job in any way. Okay, forget that. Okay, let's look down this column, because these two, right, minimum 3 and maximum 17. But that still gives a possible ratio between them of up to 5. Oh, that's why 1 is here, because the ratio is never going to be 1, as in, well, apart for a black dot anyway. So there's always going to be a multiplication ratio between black diamond joined cages. Oh, let's go back to what I was thinking about originally. Can we say that red and blue are the same? The same total, at least. They clearly could be the same total. Right. Actually, let's think about green and red. Okay, there's no repeat digits in a cage. So there are strict minima and maxima for these tetromino 4-cell cages. 10 is the minimum, 1, 2, 3, 4, for that one at least. 30 is the maximum for either of these, 9, 8, 7, 6. So the ratio between them, if it can't be 1, it must be 2 or 3. So I can get rid of Y and put 2 or 3 there. Now, what is going on between red and yellow, for instance? Red is somewhere between 10 and 30. Yellow is somewhere between 15 and 35. Let me just aide-memoire this. Red is somewhere between 10 and 30. Red is somewhere between 15 and 35. Oh, well, there are not that many possible ratios. Again, if this was the lower, if the 5-cell cage was lower, it would have to be 15 and the red cage would have to be 30, and that would be a 2. But it's more likely that the yellow cage is higher, going up to 35, and the red cage is lower, going down as far as 10. And the ratio then is 2 or 3. So this digit again is 2 or 3. Now what about blue? I mean, blue is effectively in the same position as these red numbers. Okay, well, you can't go ascending and then ascending again. Like, if that was X as a total and that was 2X, this couldn't be 4X. That would be going crazy with these numbers. So So red is the same total as blue. That was what I set out to prove here. Okay, let's get rid of those aid memoirs. Red is the same total as blue, and red has a relationship with green. Okay, maybe we can prove that's a 2. That would be worth doing. The only way it's a 3 is if one of these is 9, 8, 7, 6, and the other one's 1, 2, 3, 4. Well, that being a 3 would make this one the 1, 2, 3, 4, but it can't be. So that is disproven, and that's a 2. And now this cage has a minimum total of 14. And a maximum of 26. Oh, well, things have changed a bit. 14 to 26. And this one is minimum of 10, maximum of 30 still, as far as I can see at this stage. And now we can't have a difference. Oh, well, I've just established that's a 2. I don't know, why am I doing the same thing all over again? I am losing my mind on the hot day. That's what's going on there. No, it's not really. What is pink? If pink is obviously lower than the total of green, because green has to add up to at least 14, and pink is just 1 digit. Oh, pink times this cell, which tells us the ratio, equals green. Oh, that's strange. These two multiplied together give us the total of green. Well, there could be a 3-4 pair. What's green's maximum? 26. I suspect, I was going to say 4-6 is the highest they could go, but 3-8 would do that. Oh, but would it work? Yeah, it probably would. If this was a 3 and that was an 8, can green add up to 24? Yes, it can. That has... Oh, no, this is getting interesting though. That has an effect on red. Right. The multiplication of those two digits gives us at least 12. And this can't be 12 because it would need a 1 in it. So it gives us at least 15 with a 3 and a 5 here. Green is at least 15. Now, if that was the case, if it was specifically 15, red would have to be 30. This makes it a bit 3, 5... No, 5, 3, 4, 6. Ah, that is actually quite likely what is happening. If green is not lower than red, green could be higher than red. Red could add up to as little as, well, let's say 10 again. And then green would have to add up to 20. And obviously this goes, green can get up to 26. So 20, 22, 24, 26. Red would be 10, 11, 12 or 13. So I think red adds up to 10, 11, 12, 13 or 30. Is that mad? No, I think that's right. And but hang on, if red did add up to 10, 11, 12 or 13, making this one 20, 22, 24 or 26, this pair has to multiply together to give that. Well, 20, yes. 4 times 5 is possible. 22, no, not possible. 24, yes, in 2 ways. 26, no, not possible. So now we've got green down to being 20 or 24 or 15. And red is 10 or 12 or 30. I mean, this is very... Oh, look! Look at this connection, Mark. You numpty. It's a white diamond between orange and yellow, that is telling us, what is that telling us? That is telling us that yellow is not very high. That's what I think it's telling us. The maximum total for orange, well, it can't be 17 because that has a black dot relationship of some sort. So 16, we'll say, is the maximum. This couldn't, for instance, be 34, and it couldn't be a number divisible by 17. So 17 is impossible. Let's say this was 16, with a 9 there that also acted as the white diamond ratio. The most this could go up to is 25. And when I say ratio, I meant differential. If this has a maximum of 25, that's changed what I was thinking about quite a lot. Yellow is somewhere between 15 and 25. This changes my aide-memoirs now. 16 and a 9 is 25. So yellow is quite restricted. Red, well, we've said now, it's either 10, 12 or 30. But these all work. 10 to 20, 12 to 24, and 30 to 15. I think these are prevailing. 10 to 20, 12 to 24, and 30 to 15. These are the possible red totals, and these are the possible yellow totals. And green would be 20 in that case, and 24 in that case, and 15 in that case, just as yellow is. Green and yellow must be the same, because if this is low, these are both high. And then blue is going to be the same as red, because we proved that already. Oh, goodness. Now, let's just have a think about this having a minimum of 15 now. What would that require orange to be? It would add up to somewhere like, well, not 14, because then it would need a 1 here. It could be 12. Orange is 12 or less. How much less? How much less? That was the point. If this was 15, this can't add up to 6 because it couldn't have a 9 in. It could add up to 8 with a 7 there. Right. Orange is somewhere between 8 and 12. 8 is significant because 8's the only one that allows this to be double orange. It has a ratio of 2. It's either half or double orange. But the only way this could be 8 was with a 7 and a 1, so that we could add the 7 again as the white diamond value to get to 15 here. If this isn't 15, this can't be 8. And if it is 15 and this is 8, it has to be a 7, 1, and then you can't put 16 here because that would need another 7. It would need a 9, 7 pair. So this light blue is always half of orange. And orange isn't worth 8. Orange is worth, well, somewhere between 9 and... Oh, but yellow could be 20 or 24. It's worth at least 9. And therefore this can't be double. This must be half. But therefore orange is always an even total, and this is half of it. This is always a 2 now, isn't it? We've got a ratio between 10 and 20, 12 and 24, or 30 and 15. That digit is a 2. That might actually impact some of these blue. Oh, red can't have a 2 in it anymore. Red can't be 10 or 12. They're gone. 20 and 24 are gone. Right. Red is 30. Yellow is 15. Bingo. There we go, Philip. You are a beastie to me. Blue is 30 as well. Green is 15, and those two multiply together to give 15. They're a 3-5 pair. Now we worked out how green was made up. Does it have the 5 in? No, because they would have to add to 8 and they couldn't. So it has the 3 in, and these two add to 10. They are 4, 6. 6 is not in those cells. We've got 7, 8, 9 triple in the box. 6 is in one of the, look, this is a 6, 7, 8, 9 quad here as well. So these are from 1, 3, 4, 5. Wow, that was a mind-blowing opening. Literally, we used the values. Maybe I didn't need the values down to there once I started thinking about, well, I rather think I did. I don't know. But we've used the values of all the coloured cages. And we've now got 5, 10, no, 5, 15, that's right, 30, 15, 30. Right. Oh, this is... Right, what you can do with this orange cage is add that and 2 of them to give 15, because this acts not only as the value in the cage, but also as the difference value of the white diamond. So this, this had to be even, remember that. So this is odd, and this is odd. Both of them are odd. This is odd because that gets the differential up to the value of 15 after you've got this even cage added in. We know this is even because that's half of it. That's what we were doing. So this is an odd digit, 3, 5, 7 or 9. 15 minus 9 would leave 12 for the value of the cage, so that would be a 3. 15 minus 7 would leave 8 for the value of the cage, so that would be a 1. 15 minus 5 would leave 10 for the... Hang on, I can't have done that right. 15 minus 9 makes 12... No, it makes 6 the value of the cage. 9's impossible. Yeah, that's better. Yeah, that's true. 15 minus 7 makes 8 the value of the cage. 7, 1. We worked that one out. 15 minus 5 needs another 5 there. That won't work. 15 minus 3 is 12. Then it can be 3, 9. Okay. This cage is either 3, 9 or 7, 1. So it's adding up to either 8 or 12. It's not adding up to 8, because if that was 7, 1, this would have, well, this couldn't be, we worked out earlier it couldn't be 9, 7 because of the 7. Now we can work out it couldn't be 1, 3 because of the 1. So this is a 12 cage in that order. And 12 plus this difference of 3 makes 15. Okay, good. Now, this is adding up to 6. Can't be 24, and it doesn't use a 2. So that's a 1, 5 pair. This digit has become a 4, de facto. 9 is not in those cells, so it is in those two in the row, and not in those. This digit is 6, 7, or 8, and we do know the white diamond value in this column, but we don't know whether we're adding to that. Oh, we've used 1, 2, and 3. Oh, lovely. So we're not getting a smaller number than 6, 7, or 8 into here, because we would have to use a 1, 2, or a 3 to achieve it. So well, the least digits we can put in here are 4, 5, which is the most that this cage can ascend to once you add the white diamond. So 8 there, plus the 1 value in the column gives 9. There we go. So that has sorted out the rest of the red cage. This is an 8, 9 pair. And this is a 6, 7 pair. This can't be 3. Have we got any more tidy up on the yellow? Not really. This column, though, we can finish, well, apart from the 4, 9 cage, I think, we can finish it. Now, that 5 is looking down at this cell. That's a 4. Just tidying up my Sudoku. Now, where do I go next? It's not obvious to me to see what I do next, because each one of the remaining diamonds in the puzzle, we've yet to know its difference or its index number. Oh, look, that is 4 or 5. That's the difference ratio between this 2-cell cage and this 6-cell cage. Oh, this is maybe a little bit limited, is it? Not really yet. Well, it can't have 2 digits from 1, 2, and 3. I think the least this can be at this point. Oh, hang on. 8, 5, 1 have to be placed in box 5. So that is a 5, 1 pair. Oh, that's just Sudoku. Come on, Mark. 1, 4, 5, 6 still to place there. Right. Now this grey cage, hang on. First of all, that's a 2, 3, 4 triple. The difference between this cage and this cage, so let's give this a colour. The difference between this pink and this dark green is 8. I don't know how to use that. But the multiplier between grey and dark green is 4 or 5. And this cage, well, it can't be a 2, 3. In fact, it's going to have to use 1 digit higher than 5, because there are only 5 digits of 5 or below in the column, and 4 of them have been used. So this is going to be, at an absolute minimum, a 2 and a 6, adding up to 8. And then we have to multiply. There's no question of divide. We have to multiply by 4 or 5 to get to this. And it's at least 8. And that's going to take the value of dark green to, well, if we used 5, it would be wrong, because that would take it to a value of 40. And the maximum value for a 6-cell cage containing 9, 8, 7, 6, 5, 4 is 39. So 5 is not the multiplier, 4 is the multiplier. We've finished column 1. Now, this is either 8 giving 32 or 9 giving 36. There's no other option. Dark green is 32 or 36. We can't go up to 40. So grey has a value of 8 or 9. It doesn't use the digit, I was going to say it doesn't use the digit 7. It doesn't use the digit 8 or 9. It is a value of 8 or 9. I don't quite, oh, well, hang on, let's say, oh, we've got this connection between dark blue and green. Right, green is either 32 or 36. Because that's 8 or 9. This is 4 times that, 32 or 36. Compared to a value of 30, what does that make this? Well, it's not allowed to be 2 up here, so it's 6. Green has a value of 36. Grey has a value of 9. It's either 2, 7 or 3, 6. This is 36. Its difference to this is 8. So this is either 44, which it isn't, or 28, which it is. So this pink cage is worth 28. These digits are from 2, 6, 7, 8 by Sudoku. In fact, we need a 9 in this column. It's very clear to suddenly see where that is. So this is 28. No, yes, 28. This is 36. 36 connects to this cage by a black dot. Oh, I've just noticed these cages aren't even connected to the mass. Anyway, these are therefore a factor of 36, and that cage's total multiplied by this digit gives 36. Well, it can't be 6 times 6. And this single digit can't be 1, 2, or 3. It's got to be a multiple of 36 itself. So it's 4 or 9. Yeah. And this cage is worth either 9 or 4. and then multiplying them together gives this 36. That's fine. So this is either a 3-1 gauge or 1 and 3 here, or it's got a value of 9 and that's a 4, in which case it can't be 4, 5 or 1, 8. It would have to be 2, 7, which it can't be because of this row, or 3, 6, which would require a 6 there. Both versions need a 3 here. Isn't that bizarre? So this is a definite 3, and this cage, I haven't coloured it yet, is either worth 9 or 6. Now we've got a 2, 3, 4 triple there. These digits are 6, 7, 9. Ah, well that tells us that this is a 1. And that means this cage sums to 4 and it multiplies by a 9 to give 36. And that's now not a 9. These don't have a 1 in. We can do the 5 and 1 in the central box. This is a 2, 8 pair. I mean, I don't know. We might be getting some traction on this, but it feels a little hard to spot any. Now, this is 36. What did we work out pink was? 28. That might be having a bit of a hard time. Maximum so far is 7 plus 4 and 3 is 14. These have a minimum total of 14, and we can't use 5 or 8. So we're using 6, 7 and 9. We're definitely using 9 because one of 6, 7 has gone into grey here, so we can't use them both here. So, if that was worth 16, 9 and 7, these would be worth 12. That would have to be a 6. I don't think this can ever be a 2. If this was a 2, they would be 3 and 4 in the same cage. And these would both have to be 9s. Right. Oh, I'm going to have to start colouring 6s and 7s, I imagine. I might have to uncolour all my cages, which is a shame. Let's put that off anyway. I've also got this cage to make add up to 36. I've used this cage as 36 total so many times in this puzzle. It's weird that I haven't actually started working out what its digits are. But such it is. That is the case. Let's put in the possible digits in row 7. Okay, so 6, 7. That is now a 6, 7, 9 triple in a cage that adds to 28. Those are 22. This has to be a 4, 2 pair. That digit is a 3 by elimination. This cage is going to add to 32. It's the missing digits from 1 to 9. You know, I'm sure, the secret that all the digits from 1 to 9 add up to 45. I've probably used that to some extent already somewhere, but it's true. So the cage, the digits that aren't in this dark green cage add up to 9 because there are 3, and there are 3 of them. Oh, and they're not 2, 3, 4 or 1, 3, 5 because 3's in the cage. So the digits missing from the cage are 1, 2, 6. So that cell has to be 7. This one has to be 9. This one can't be 1, 2 or 3. And these are a 5, 8 pair. And I think we'll find that we are now adding up to 36. 13, 16, 20, 29, 36. There we go. That was all so doable. This is a 6. This cage is getting quite interesting. I will look at you in a moment. Other cage. Now, 5, 8 pair there. And there's an 8 in one of those cells. So there has to be an 8 somewhere up here. 6, 7, 9 here. 2, 8. I mean, this cage is done. This cage is done. This one is either a 3, 6 or a 2, 7 pair. Oh, 6 there has been looking at this cell for a long time. That stops this being 6. One of these 3 is a 6. That doesn't necessarily tell me which cage it's in, I don't think. So I'm looking for something else to do now. That's not a 1. Okay, we've got yellow is 15. Oh, we don't know what this is, but there's a... Okay, so let's make that grey and this light blue. Yellow to grey is a difference of that, which is 4, 5, 7 or 8. From 15, can we possibly go down? What's in this grey cage? What's in this bit of it? Not 2, 3, not 4, 5, 6. So these are digits from 1, 7, 8, 9. And this one is not 6, 4, 5 or 9. So grey is a bit limited. I'm also wondering about light blue. And there's 6 difference between that and this. So we've got 15 here. The trouble is this can be anything. That can't be 7. This can't be 4. I should do some tidying up, I know. A 5, 8 pair there is looking at this cell. That's a 2. That's not a 2. That's not a 7. 4, 2, 5, 8. Look, this is a naked single because of that 5, 8 pair. So he's 2, 4 in the row, 1, 3, 7, 9 in the column. That's a 6. This can't be 6. This can't be 6 either. Let's look at this column. We've got 2, 4, 5 to place. That becomes a 2. And that is going to take 2 out of that cell at least. Look, 6, 6. Where does 6 go in column 7? Definitely there. Oh, it's funny this. This is... Oh, and now I am going to look at this cage. Because if they add up to 8... the difference is 7, 6, 5 or 4. All of those digits virtually can go here. That's a shame. If they add up to 14, the difference is 10, 11, 12 or 13. None of those are digits that can go there. So this can't be an 8. It's taken me a long time to see that. I know. That's an 8. This is now not an 8. This does add up to 8. This can't be a 2 anymore. So actually the difference is either, well, this can't be a 4 because that would have to be another 4. So it's either a 3 with a 5 there or a 1 with a 7 there. 3, 5 would make this 1, 4. 1, 7 would make this a 4, 5 pair. I don't know which it is. 4, 2, 5, 8, 6. These digits are, well, that is 1, 3 or 7. This is the only one in the row that can be 9. Pencil marking got me there. This is a weird old thing, isn't it? Right, what can this cell be? It can't be 5, 8, 4, 3, 7 or 6 or 9. So that is 1 or 2. How many places in this column could you put a 2 in? This one only. Oh look, there's a little 2 X-wing that should have told me that. Right, this grey cage has become 6, 3. That's going to help. That places 6 here. This is a 1 to finish the box. That 1 looks up to this cell. What else is going on in this column? 1, 5, 8, 9 to place. Not much, actually. How about this column? Don't know. That 3 is looking up to yellow. That looks down to pink. These digits are from 7, 8, 9 and include an 8. So they don't include an 8. That's now a 7, 8, 9 triple in the box. Oh, I think we're going to stumble into the solution here now. That can't be a 1. 1, 2, 3, 4, 6, 9 in the top row. We've only got 5, 7 and 8 to place. Only one of those can be an 8. We've found it. That's now a 7, 9 pair. So this is a 3. That's an 8. These can't have a 5 in because of the 5, 7 pair in the box. That's a 5. Down here we've got digits from 3, 4 and 7 to place in the bottom row. Now we still haven't sorted out this stuff. Okay, time to look at yellow and grey. Well, we know what this digit is, right. 15 plus or minus 4 gives this total. So it's either 11 or 19. Well, it's got to be 11, 3, 1, 7. Now, the grey total is 11 plus or minus 6 gives this? Well, it's got to be 17 with a 7 again. And there we go. That's the top 2 rows completely finished. That's literally going to finish everything, isn't it? 8, 5 here is done. 8, 9 here is done. This is not an easy puzzle, but I think we found a good way through. Now, I'm going to do this. I didn't colour these, did I? Let's give them red again and yellow. 8 minus 5 is 3. It's really quite straightforward arithmetic. We don't get a 3 in the corner, but we do get to finish the whole puzzle. And that is a blessing and a relief. There we go. Lovely stuff, Philip. XY cages all done. Super effort. And I've enjoyed myself a lot with that. That's just the sort of puzzle I like. Although I took a long time over the beginning, didn't I? Must have been, I wonder, was it 10 or 15 minutes before I finally worked out the importance of this cage in limiting things? Even that didn't quite get me there. I wonder if I did need that, or whether I was just failing to use. There was something I was failing to use. Ah, it's gone now. Anyway, I'm not unhappy with that solve. I'm very happy with the puzzle. Thanks to Philip, who tested the puzzles in the regeneration Sudoku hunt. And much gratitude to him for doing that. And we shall see you again soon. Do come and join us tomorrow for more Sudoku. Thanks for watching, and bye for now.